This video shows you how to do production order quantity. Now it's different than economic order quantity because economic order quantity we are purchasing our inventory from somebody else. And so because of that we basically are not producing it, and so we'll go from zero back up to our economic order quantity. Now the interesting thing about production order quantity is that we will produce to a certain point, and we will want to stop because that's where our holding cost equal our ordering cost or our setup cost. And so once again the idea is that both of those are minimized. Now the difference here is that while we're producing, we're also using or selling some of that inventory. So we're not going to go from zero all the way back up to that point. Even though we will produce to that point, we're actually going to carry a little less in inventory. And so you'll see that it is modified. On the formula sheet, this is the production order quantity one here. You'll see that it's modified. The setup or the ordering cost is the same, but the holding cost, because in this case this assumes that you went from zero economic order quantity because you're not producing it. You went from zero back up to that economic order quantity, and so you need to then cover the average inventory, which is the halfway point between the economic order quantity and zero. In this case, we will produce up to that point, but we will never hold that much in production order quantity. Even though we will produce to that point, we will hold less than that. And so you need to make this little modification here, which is the daily demand divided by the daily production, small p, small d. And so we'll need to figure out what the daily demand is. And then we can go ahead and use this formula to do production order quantity. And we're then going to have to make that modification on the holding here too, so that this quantity is reduced by 1 minus d over p, because that has to do with how much of it we sell over those days that we're producing. And then you divide it by 2 and times it times the holding cost. So this is what you would use to calculate the cost. And we don't have a price here because we're not ordering it from somebody else. We are producing it ourselves. And then I'll come back and talk about this when I get into quantity discounts, this slight variation, but I think I already mentioned that in the earlier video. Sometimes holding cost is not constant, it's contingent upon the price. And so depending if the price changes, then our holding cost would change in that regard. And so this large P stands for the price. So let's go back here and calculate. Let's figure out the little d then. The little d is basically we have our annual demand here, and we're going to divide it by, in this case, the data is from 12.16 auto manufacturer, car manufacturer in Indonesia, Jakarta. And they have 250 days, so the demand per day is 50. So we can produce 300. They give us this number as they can produce 300 units, but each day they'll actually be selling or using 50 of those units. Holding cost is $2 per item, and then the setup or the ordering cost when we decide to produce. Every time we decide to start producing, it's going to cost us $30 per item. So let's go through and do that formula again. So instead of economic order, we're going to do production order quantity. I'm going to do the top part of the equation again here. So this is, once again, in regards to the ordering or setup is the same, 2 times the annual demand times the setup. And so we have that. Now here's where we're going to have to make some calculations. I'm going to just do it down here below. I need to figure this out and modify that. So I'm going to take 1 minus the D, the demand here. So we're going to take the demand, the daily demand, and we're going to divide it by the production, the daily production. Now, One variation of this is that if you had the annual demand and they had the annual production, or the annual demand and the annual production, we could take the 300 and times it times 350, and we could use the annual demand divided by the annual production, as long as they're both in the same units. So I could have easily taken this production and multiplied it by 250, and that would have been my annual production. And I just need the ratio, but in this case I decided to modify the demand. So as long as they're both in the same period of time and that ratio is correct. So that's the little part that I need, and then of course we're going to multiply that by H. So this is this times that modification, because we only have 83% of the inventory. So we do not have 100% of the inventory, and so we made that modification. Now, of course, like we talked about, you simply then divide this by this new holding cost, or that modified holding cost, and then we take the square root of that. We'll just put it here, the SQRT, square root. We use that function, and that would give us our production order quantity. So we would produce 670 units at any one time. The idea being that then the nice thing about this is there is no real order point. So 671, if we were to round up based on that, there is a reorder point, because what happens is when you get to 0, then you just start producing, because we're not getting it from somebody else. As we're producing, there will be a certain amount of demand met as we're producing. We actually produce more than the demand, and so that will build up inventory. So when we get to 0, we start producing again, and we produce 671, and then we stop, and then we let that get back down to 0, and then once again we start producing. Now let's show you how to calculate these, the number of production runs then. That's one of the questions they ask, number of production runs. So how many times, instead of how many times you're going to order, how many times are you going to produce? Well, think about that. This is pretty straightforward. If this is the annual demand, and they tell you every time you're going to produce this amount, we will produce 18.63 times in a year. So 18 times we will start the manufacturing process, and we'll produce 670. Now here's the interesting thing, the what we call the maximum inventory level. It is not going to be 670, because as I told you, some of that's going to be used. So maximum inventory is basically the Q times that 1 minus. So we told you that we're going to do this. This is the Q, the production order quantity. But really we're not going to store that, because some of that is actually, even though we produce 671, some of that is already going to be used or sold in demand. And so we want to multiply that by this equation here. Once again, the 1 minus D over P. I'm sorry, not that one. I think that might be the correct one. Let me double check. This one, yeah, this is the 1 minus D over P. So the biggest amount we would hold is 559. So that's the maximum amount of inventory. Even though we produce 671, we're actually, the highest amount of inventory we will ever have holding is 559 units. And so to get the average inventory would be half of that. So we can actually calculate out that this idea. The other thing you can do is they wanted to know the days of demand satisfied by each production run. Days satisfied by production. We can calculate that. Days satisfied production is just the 250 days divided by this. And what that tells us is that 13.42 days, that basically every time we produce, we meet 13 days. And so this is the number of days in between order. This is the number of days in between production, that we can meet the demand for 13 days by producing every 18 days. We can meet that demand. 13.42 days is met. Time of production for each order, another interesting one, 671, which would be the amount that we're producing divided by 300, which is the production. So it takes us 2.24 days to produce that amount. That should make sense to you. So if this is what we're going to produce, and this is how much we can demand, or we can produce per day, it takes us 2.24 days to produce that. And then, of course, we're going to do, to meet all of the demand, we will be able to do that in 13.42 days. Let's quickly calculate the cost out here. I wanted to show you this one before we leave this problem, because it's a little bit different. So once again, we'll figure out the inventory cost, or I'm sorry, the setup cost is that we're going to basically do this number of production runs times every time we do the setup is so $559 is the cost of that. And then let me show you what we mean by this is, so these should be once again equal to each other. Even though we produce 670, remember we're going to take then this idea where this is really how much we will totally, because some of that inventory, even when we produce 671, some of that is sold off. So the highest we're ever going to store is this amount here. And so once again, the halfway between the maximum inventory and 0 is 2, and then we'll times that times the cost of holding. And you'll see that they are equal to each other once again. And so the cost of managing this inventory is both these ideas. They've minimized these costs again and made them equal to each other, and that is production over quantity. So the cost of managing this inventory is $1,118.03. So that is the basic idea behind production order quantity.